Hi, this video is going to look at solving problems involving angle properties of polygons. The learning goal for this video is to solve complex problems involving angle properties of polygons. So we're going to look at 3 examples of problems that will give you a flavor about some of the problems that you might encounter when you're being asked to do some problem solving using angle properties of polygons. So one important property that we're going to be using a lot in this video is this, the sum of the interior angles of polygons. So no matter how many sides there are of a polygon, there are always 2 less triangles inside them. Okay, if you cut them up in like a picture that's there on the right hand side. And so because each triangle has 180 degrees, all we need to do is we just take the number of sides of that polygon, we take away 2. So that's the number of triangles, and then we multiply that by 180 degrees. So another way that we can look at it is using that formula there. So S is equal to n minus 2 times 180. So S is the sum of those interior angles, and n is the number of sides of that polygon. So if you know the number of sides of a polygon, you just take away 2 and then multiply by 180, and that will get you the sum of those interior angles. So let's look at a problem here involving angles inside of a star. So determine the sum of the angle measures in the corners of this star. So in other words, A plus B plus C plus D plus E. If you'd like to try the problem yourself, you can pause the video now, and then after you've given it a try, then you can press play. So what you can do is you can see here we have a 5-sided shape inside, right? A pentagon, and it's a regular pentagon because each side here with the dash marks here is showing that they're all equal. So you can use this relationship here again. So the sum of those interior angles is equal to n minus 2 times 180 degrees. So n's the number of sides. So there are 5 sides to this shape. So I'm going to write 5 minus 2 times 180 degrees. So that will be 3 times 180 degrees. So inside of that pentagon, there is a total of 540 degrees. Now, this is a regular pentagon. So what I can do is I can actually find out the measure of one of these angles, or each of them. So I can do 540 divided by 5. So that'll be 108 degrees. So each angle here is 108 degrees. Now, I would then know what the angle here would be. Okay? I would also know what angle that would be. So that blue angle there combined with that angle of 108 degrees must be equal to together 180 degrees. So what I can do now is I can find out the measure of those blue angles. So 180 degrees minus 108 degrees is 72 degrees. So each of these angles here is 72 degrees. Now, if I want to find out now that angle A, I know in any triangle that the sum of these 3 angles inside of a triangle is 180 degrees. So let's do 72 plus 72. So 72, plus 72 is 144 degrees. So that angle A there, okay, that angle A is going to be 180 degrees minus 104 degrees. So A is going to be 36 degrees. Now, we can repeat that 5 times, okay? But because each of these angles inside are all 108 degrees, okay, we're going to have the exact same situation in each of these 4 other triangles. So A is equal to B, and that's equal to C, which is also equal to D, which is also equal to E. So all we need to do, okay, to find out the sum of A plus B plus C plus D plus E, okay, A plus B plus, C plus D plus E, that's just 36 degrees times 5. Right? There's 5 of them. Okay? So that would be 180 degrees. So that involved using the sum of the interior angles and also knowing what a straight angle is, and then the sum of the angles inside of a triangle. All right, let's look at another problem. Here we have a diagram, complicated looking diagram. We need to find the values of angles x and y. So again, if you want to give this question a try, pause the video, and then when you have a solution, you want to see one, press play. All right, so usually in a problem like this, you're going to need to find angles that of these sides as much as you can. And then we'll lead you to find out what an angle x is, and then we'll help you to find angle y. So let's just try to uncover some angles, okay, that might be useful. So I know actually here, if I know what the angle of, what the measure of this angle is, then I'll know what x is, okay, because these two angles need to add up to 90 degrees. Okay? So I can see that if I only knew this angle, then I would know two angles in a triangle, which would then help me to find this third angle. And I can tell now I know how to find this blue angle because it's the opposite angle to this 85. So I know that this angle is 85 degrees. Now, because I know two angles out of three in a triangle, I can automatically find the third one. So I can just add these two. So 85 plus 65 is equal to 150 degrees. So this red angle here is just going to be 180 degrees minus 150 degrees. So that angle here is 30 degrees. Now that will help me to find what angle x is. Okay? X is equal to 90 degrees minus that 30 degrees. So x is 60 degrees. Okay? So that will help me because now I need to find this angle y. Okay? I can tell what this angle is. Okay, so let's try to find some angles inside of this 1, 2, 3, 4, this quadrilateral here. So I can find out what this angle is because this is this combined with 85 is a straight angle. Okay? So if I do 180 degrees, take away 85 degrees, okay, that will give me 95 degrees. So I can tell this angle here is 95 degrees. I know that that's 60 degrees. If I only knew this one, then I'm just left with the angle y, and I can find out what that is. So I can use green. Okay, this angle here with 108 together, again, is a straight angle. So if I do 180 degrees minus 108 degrees, that will get me 72 degrees. So this angle here is 72 degrees. Now, if I have all the angles except one, I can find that missing one. I know that the sum of the angles in a quadrilateral in a four-sided shape is 360 degrees. So let's add those three angles together. So I have 95 degrees plus 60 degrees plus 72 degrees. If I add them together, I get 227 degrees. Now again, the four angles inside of a quadrilateral is equal to 360 degrees. So I know that y is 360 degrees, take away 227 degrees. So y is going to be 133 degrees. Okay. So it's really in this problem uncovering angles inside of a shape, okay? Not ones that you need directly at first. Okay? So you notice that I worked backwards in this problem. I said, oh, if I only knew this little angle here, okay, I would be able to get x. So then I went backwards to say, okay, well, if I only knew this blue angle 85, then I would be able to get this red angle here. Okay, so then, and then I thought, oh, okay, I know how to find that one. So a strategy would be to work backwards, starting from what you really need to something that you need to find out what you need, and so on and so on. Okay, let's try this last problem here. So here's another diagram. Let's find the values of angles x and y. So one more time, feel free to pause the video and give it a try, and then press play when you're ready to see a solution. So the first thing I can see here is, well, I know for angle y here, I know this angle is 85 degrees, this is 70 degrees, and this here is 90 degrees. Okay, so again, if I know 3 out of the 4 angles in a shape, then I can find the fourth one. So let's add 90 degrees with 70 degrees with 85 degrees. So that's 160. So that's 245 degrees. So angle y here is 360 degrees. Take away 245 degrees. So y is 115 degrees. Now let's look at angle x. So these are all labeled angle x, so that means they're all the same. So in a 5-sided shape, remember, if you don't remember the sum of the angles in a pentagon, we can always use this relationship, right? S is equal to n minus 2 times 180 degrees. So this is a 5-sided shape, so I'm going to replace n with 5. I'm going to subtract 5 minus 2 here, so that's 3 times 180 degrees. So that's 540 degrees. So I know that all 5 angles put together will be 540 degrees. These 2 angles on the bottom here are already each 100. So if I do 540, take away 100, and take away another 100, I am left with 340 degrees. So that's how many degrees are left to share amongst these 3 angles. So x here, I can do 340 divided by 3. Okay, now, I can't divide that evenly, so if you wanted to leave that as a fraction, you totally could. Or if you divided them, you'd get 113.33, and so on, degrees. Okay. So, one more time, it's important to understand this relationship and to find out the sum of the interior angles, because those facts are going to be very handy when you're trying to find a missing angle. Okay? So hopefully those examples have made things a little bit more clear about solving some complex problems involving angles in polygons.